6.4 part 3 is going to be writing equations from graphs, and we've done this, only the difference is, if you notice here, our graphs, these lines, you're not, let me get rid of this here. You're not going to be able to tell where the line is crossing the y-axis. So the other ones we did, you could tell where it crossed the y-axis. This time, that's not a clear number, and so we're going to have to do a little bit of work to figure out where that y-intercept actually is. So what we're going to do, just like anytime you're writing the equation of a line, you need to know what the slope is. So to find the slope, I have these 2 points on my line, and I need to do rise over run. So I'm going to go down to 3, and I'm going to go over 1, 2, 3, 4, 5, 6, 7. So that's a slope of 3/7, but notice that my line from left to right is going downhill, so that's a negative slope. I can't reduce that fraction, so I'm going to leave it as is. Then the second thing I'm going to do is I'm going to need a point, and I do have a point. I have 2. You could use either one. I'm going to go ahead and use this one right here, that point. And the coordinates of that point, I do my x value first, is 3, comma, negative 4. And so I'm going to use the point 3, comma, negative 4. So remember, if I have a point and slope, we're going to start in point slope form. So I'm going to do y minus my y coordinate, which is negative 4, equals m, my negative 3/7, times the quantity x minus my x coordinate of my point, which is 3. And remember, this double negative over here, y minus negative, is actually a plus sign. And so there's my equation in point slope form. Now I'm going to take that equation and I'm going to put it in slope intercept form, which means I need to solve for y. So the first thing I need to do is distribute this through. So negative 3/7 times x is negative 3/7x. Negative 3/7 times negative 3 is a positive 9/7, and then equals, and then I'm going to bring down my y plus 4. Then my next step, I'm going to subtract 4 on both sides because I'm solving for y. So I have y equals plus 4 minus 4 cancels, negative 3/7x, and then you can just do this on your calculator. So you're going to take on your calculator 9, and then the ABC button 7, and then minus 4, and that's going to give you negative 2 and 5/7. This is how your calculator will spit it out, or if you want to write that as an improper fraction, that would be negative 19 over 7, and you can write that either way. So there are my answers in point slope form and in slope intercept form. On to the next slide. I'm going to do the same thing here. So I'm going to find the equation of this line here. And so I'm going to do that. Whoops, let me scroll down here. So remember, the first thing that we're going to do is we're going to find the slope of the line. So to find the slope, I'm going to go down first, and I go down 1 and over 1, 2, 3, 4, 5, 6. So the slope of this line, 1 is on top because that's my rise, up or down, 6 is on bottom, and again, my line is going downhill, so that's a negative slope. And then I need to use a point, so I'm going to use this point. Anytime there's a point in the first quadrant, I'm going to use it because I love positive numbers. So the x value of that point is the number 5, and the y value is 2. So we're going to use the point 5, comma 2. And again, when you have a point and slope, you're going to start in point slope form. So I have y minus, my y coordinate is 2, equals my m, which is negative 1/6, times the quantity x minus my x coordinate, which is 5. There are no minus and negative, so there's nothing to simplify. There's my equation in point slope form. Now we're going to put this in slope intercept form. So the first thing I need to do is distribute across the parentheses. So negative 1/6 times x is negative 1/6x. Negative 1/6 times negative 5 would be a positive 5/6. and then I'm going to bring down y minus 2. And then my final step would be add 2 because we're trying to get y by itself. Left to right, bring down my y equals negative 1/6x. And then again, you could do this on your calculator. 5/6 plus 2 would be 2 and 5/6 if you wrote it as a mixed number or as an improper fraction. That would be 17/6. However you write it is fine. And there are my two equations for the second example. Next, okay, my third one. So let's move this so we can see the line here a little better. Okay, so again, to write the equation of a line, I need to know my slope. Slope is always rise over run. So I'm going to start at this point right here, and we're going to go down 1, 2, 3, 4, 5, and over 1, 2. So 5 is my top number, 2 is my bottom number. Notice again, my line is going downhill, so that's a negative slope. Then I have a point on my line that I'm going to use, and I'm going to use this point right here because any point on an axis means one of the numbers is 0, and that's a little easier to work with. So this point would be the point. 1 is the x-coordinate. I don't go up or down, so my y-coordinate is 0. And so we're going to use the point 1, 0. Again, I have a point and slope, so we're going to start in point slope form. So I'm going to do y minus, my y-coordinate is 0, equals my slope, which is negative 5/2, times the quantity x minus my x-coordinate is 1. And you can leave it like this, or if you want, instead of saying y minus 0, you can just write that as y. Either way, either one of these answers would be correct for point slope form. Now we're going to put it in slope intercept form, so we need to solve for y. So we're going to distribute negative 5/2 times x is negative 5/2x, and then negative 5/2 times negative 1 would be positive 5/2. And then you're just bringing down this y because it's just subtracting 0, which doesn't change anything. And so this is my equation, since y is already alone, in slope intercept form. And so I didn't say this in the other one, but what you should notice is my y-intercept is 5/2, which if you plug that in on your calculator, that would give you 2.5. And if you go over to your graph, it should look like, if you notice here, I'm crossing the y-axis right there, which, yes, that matches, is the point 2.5. But we didn't know that until we did the work to get there. Last example. We're going to write the equation of this line. And again, we are first going to find the slope. You always need to know the slope to do the equation of a line. So I'm going to start with this point right here. I'm going to go up 1, 2. I'm going to go over 1, 2, 3, 4. So my slope is 2/4. Notice my line this time is going uphill. So that's a positive slope. And I can reduce this fraction. Both of these numbers are divisible by 2, and so my slope is going to be 1/2. We always want to write our slope in simplest form. And then I'm going to get a point, and again, I'm going to use a point in the first quadrant whenever I can because they're positive numbers, and this is the point. The x-coordinate is 3, which I always write first, and the y-coordinate is 1. And so I'm going to use the point 3, 1. Again, it doesn't matter which point you use. You will get out the same answer for your slope intercept form either way. So once again, I have a point and slope, so I have to start in point slope form. So we do y minus, the y-coordinate is 1, equals our slope, which is 1/2, times the quantity x minus our x-coordinate is 3. There's nothing to simplify. There are no minus and negatives there, and so there's my answer in point slope form. Now I'm going to put it in slope intercept form, so I'm going to solve for y. So I'm going to distribute 1/2 times x is 1/2 x, and 1/2 times, that's a negative 3, would be negative 3/2 equals, and then I'm going to bring down this y minus 1. Final step in solving for y, getting it by itself, is to add 1 on both sides. So I bring down my y, minus 1 plus 1 cancels, equals 1/2 x. And then again, you could do this on your calculator. Take negative 3, ABC 2, plus 1 on your calculator, and you would get out negative 1/2. And there's my equation in slope-intercept form. And then we could check that. So this is saying that the y-intercept is negative 1/2. So if I go over to my graph, yep, it looks like it's crossing the y-axis at negative 1/2. So it looks like we did that correctly. And that concludes our 6.4 Part 3 notes. Whoops.